Let's try another example. This one's slightly more complicated. We can't directly use the SIT VIP mnemonic because we actually don't even know what this EMF is. We're given some other clues though, and just like a crossword puzzle, we're going to fill in what we know. What we're already given here is that the current through R3, which I'm going to fill in here, is given as 2 amps. So we know that's 2 amps right there. So what I'm going to do is I'm just going to still redraw this, even though I don't know what the EMF is. I'm just going to redraw it over here. Got the same EMF, which I still don't know. That's E. I've got this R1 is 4 ohms right there. I've got this 12 ohm resistor. This is R3 is 12 ohms. And you may say, okay, well, this 12 ohm is in parallel with this one right here. You got to take a close look, though. Those are not in parallel. Notice that the current splits right there, which is not directly before this one right there, and it joins together back there. So these two are not in parallel. What can I do then? Look at this one and this one. Those are in series. Those I can redraw. In fact, I'll redraw them like this. Here is my equivalent resistance right there, which I'm going to call R24. R24 combination of R2 and R4, well, those are in series, so that's just 12 ohms. That is an easy equivalent resistance. Now what I can do is notice that right here, these two are in parallel. Those are in parallel right there. So, and we can use that little trick that if we have two identical resistors in parallel, it's just like here's one resistor and then you double the cross-sectional area, that cuts the resistance in half. So I can redraw these, if I needed to, as one 6 ohm resistor. I may not even need to do that. Let's go ahead and figure out what we can here. Because I know that the current through this is 2 amps right here, I can figure out the voltage drop across this. Delta V across 3 is I through 3 times the R of 3. And that's going to be given as 2 amps times R3 is 12 ohms. And that's 24 volts. Let's go ahead and fill that in. Delta V across R3, 24 volts. Sweet. Now, what else do I know? Well, hey, this is in parallel. In fact, R3 is in parallel with R24. So I know that delta V across R24 is also equal to 24 volts. So that will allow me to now figure out the current through 2,4 is equal to delta V across 2,4 divided by R24. Notice that the subscripts always will agree with each other here, and that is 24 volts divided by the equivalent resistance 12 ohms. That is 2 amperes. Well, hey, we could have figured that out conceptually. It's got to be 2 amperes through here as well because it's completely symmetric. And the voltage drop's the same across both, so it's got to be 2 amps through that. Once I know that it's 2 amps through this equivalent resistance, now I got to go back to my original drawing. If it's 2 amps through the equivalent resistance, which is really a combination of these two, that's 2 amps. What's the current through this one? Well, that's easy. The current through 2 is just 2 amps. 2 amps through there. What's the current through 4? It's 2 amps through there. And then now I can go and figure out what's the current through this one right there. Well, hint, this is like a river splitting into 2 creeks. Each creek has 2 amperes, 2 coulombs per second flowing through it. What's the current through R1? It's got to be the sum of those. So that's going to be current through R1 is 4 amperes. Now I'm in a position where I can figure out the EMF of my battery, and I'm just going to stop there. When we get that, so you can figure out the rest on your own. But notice that the EMF across the battery from there to there is the same thing as the EMF from there to here. Why is that true? Well, this is just a conductor right there, so there's no delta V across that. So if I can just find the delta V from this point right here to this point right there to that point right there, I've got the EMF across my battery. Well, that's going to be easy to figure out. All I got to do is add up the voltage drop across R1, let's go ahead and figure that out. Delta V across R1 is equal to I1, we already figured that's 4 amps, times R1, 4 amps times, as given, it's 4 ohms. That is going to be 16 volts. Delta V across R1, 16 volts. What's delta V across this one? We already have that. It's 24 volts. So what's the total EMF across that? It's just the sum of those two. The voltage drops add. That is 16 plus 24. EMF across the circuit is 40 volts. And then you could also figure out the voltage drop across that. That'll be 16 volts. Voltage drop, because it's just 2 amps times that. Voltage drop across that will be 2 amps times 4. It'll be 8 volts. So we can just fill those in real quick too here. And that'll be 8 volts across there. Across this one will be 16 volts. And it should be, notice that this 16 right here, this 16 and this 8, which is the voltage drops across this and this, they have to add to the voltage drop across this because those two, the equivalent resistors are in parallel right there. And then you can figure out the powers as you need to.